Okay, so I am back and we are taking notes on solving linear systems of equations. Again, this should be review. You guys have worked on these already in Algebra 2 if you're in that class, and so hopefully this will be just a good reminder, refresher, and it is definitely preparation for what we're doing next week, Monday and Tuesday, which is linear inequalities and systems. And so it's just a good review. It's stuff that you should know, and I know this makes me sound a little bit nerdy, but it is one of my favorite lessons. I love teaching systems. I think they're just so fun. So you can see on the board there are 3 different methods to use. You have graphing, substitution, and elimination. I know there's a lot of writing on there. Don't panic. You've got enough time to write it down, and we will take the time to do that slowly. So let's talk a little bit about graphing for a minute. Okay, so when we're talking about graphing, you're going to say, when do you use it? And I have 2 options there. Number 1, both in slope-intercept form. If both of your equations are in slope-intercept form, y equals mx plus b, it's definitely your best option. The other option is when y has a coefficient of 1. It's easy just then to add or subtract the x or move the constant or whatever it needs to be to do that. How do you do graphing? You're going to put both equations in slope-intercept form already. You're going to graph both lines, and then your solution is the point of intersection. So if you write nothing down in that section, that's the one thing I want you to remember, is that your solution is the point of intersection, and that matters. Okay, substitution is your next option. I think it is probably the method that students struggle with the most, and so we're going to practice it a couple of times today just to make sure you really have it solidly squared away in your head, because substitution is hugely important. Okay, so number 1, an equation is always solved for a variable, an equation is already solved for a variable. That's when you want to use it. So if you have an equation that says x equals blah, 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 or you have an equation that says y equals blah, 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 that is by far the best option if you already have it by itself. When do you use it? Second option, you would use it when a variable has a coefficient of 1 or -1. Again, it's easy to move things away. You are avoiding fractions, which makes it easier to solve, and so that's your option. How do you do it? Step 1, get your variable by itself. Once you do that, you're going to take that value, you're going to plug it into the other equation. So you can't plug it back into itself. You have to plug it into the other equation. And then number 3, you're going to solve that equation and plug that into the first equation to get the other variable. Sounds a little bit confusing. When we go through your notes in a couple of minutes, you will see a bunch of examples of it, and so I'm not too worried. You'll see it and you'll understand it. Okay? And then your last option is elimination. When do you use it? When your equations are already in standard form. When do you use it? When your equations are in standard form. So go ahead and next to that write ax plus by equals c. Ax plus by equals c. You need to have your equations in standard form because you need to have your x's, your y's, and then your constants all lined up. So that matters. So think about doing that. Number 2, you're going to multiply one equation or both equations, it depends on what you need to do, so that one of your variables has a coefficient that is opposite. So you would need perhaps 5x and -5x, or 2y and -2y. So you need them to be opposites. Once you do that, you're going to add them together. So think about what's going to happen with those opposites. If I add 5 and -5, I'm going to get 0. Or 6 and -6, if I add them, I'm going to get 0. So the idea behind that opposites concept is that when you add opposites, they're always going to cancel out. And that's why this is called elimination. So you're eliminating one of your variables. Once you do that, one of your variables is going to be gone. You're going to solve for the other one. So let's say you eliminate y, which means you'll know what x is, and then you're going to take that x and plug it back into either equation and get your answer. What I do want you to notice is this note over here on the side right here. A solution should be written as an ordered pair. So all of your answers need to be x, comma, y. If they're not x's and y's, then you should write them in alphabetical order. So like a comma b, or m comma n, or whatever it might be. But solutions should always be written as ordered pairs, and they should definitely have alphabetical order. Okay. All right, so let's go ahead and down and move to your examples. Okay, so you're looking at that first example, and you are realizing that you need to decide which method you're using and then answer the question why. It is up to you what method you want to use. You can pick. I would say let's go ahead and use elimination because they're already in standard form, so that should be it. And your answer of why is standard form. Okay, so let's go ahead and do that. Again, you can choose to work with x's or y's. It's up to you. Let's say we're going to work with x's, and that means that we need them to be opposites. Right now that has a 1, that has a 2, so we're going to multiply the first equation by -2. So negative 2x minus 2y is equal to a -8. Second equation doesn't change at all. Okay, so we're going to go ahead, since we've got our opposites, add them together. Those x's cancel out, so we don't have to worry about them. Negative 2y plus 3y would be 1y, or just y. And then negative 8 plus 9, when you add that together, negative 8 plus 9 is going to get you that 1 that you were looking for. Okay? Once you know that y is equal to 1, you're going to plug it back in. It doesn't matter which one you plug in. My opinion would be that the first one would be easier, but either one should work. And you're going to plug that in for y. You know what y is equal to. So you have x plus 1 is equal to 4. Subtract that 1. X is equal to 3. And to give a final answer, it should be an ordered pair, 3, 1. 3, 1. All right, let's go to our next example. Number 2, which method are you using and why? Again, you can pick whichever method you want. The one that makes the most sense to me would be substitution. Okay. The reason that I'm picking substitution is that y is by itself. If y is by itself, it's definitely best case scenario. So if I like to number my steps for substitution. Substitution, step 1, y is equal to negative 3x. It's basically already done for you. You don't have to do any work. You have y by itself. Second step, take the other equation, and if you have y by itself, you're going to replace the y. So 6 and then parentheses. Always put in whatever it is in parentheses. So 6 times negative 3x minus x is equal to 38. You only have x's in your equation now, right? You have a negative 3x, you have an x. Because you only have x's left, you're able to solve this equation. So you have negative 18x minus x is equal to 38. Put your x's together, right? Those are like terms, so negative 19x is equal to 38. Divide by that negative 19, and x would be equal to a negative 2. Take that negative 2, and step 3, you got to plug it back in. Y equals negative 3x. You're going to plug it in there for x. So negative 3 times negative 2. So y is equal to a positive 6. And so when you talk about your solution as an ordered pair, negative 2, 6. Okay? So that is substitution. The next one, which method are you going to use? I hope it occurs to you that both of those are already in slope-intercept form. So you're going to graph that one. Even if you don't really want to graph, I'm going to make you graph anyways because it's good practice. So the reason is they're in slope-intercept form. So let's go ahead and graph them. Yeah, you're right. I didn't give a graph on your paper, so you're going to have to do it yourself. You can handle it. I think on your homework I gave you graphs, so you'll be okay. First one, y is equal to negative x plus 3. So go to 3 on your y-axis, put a point. Then from there, you're going to go down 1 and right 1, down 1 and right 1, down 1 and right 1. And draw your line. Ooh, my graph is a little bit rough because this pen is hard to control, so hopefully your graph will be better. You're going to put a point there at 1. You're going to go up 1 and over 1, up 1 and over 1. And when you do that, you've got your line. Remember, your solution is where your points cross, or sorry, where your lines cross, the point where your lines cross, the point of intersection. And if your graph is a little bit more accurate than mine, it should cross at 1, 2. Okay? Let's go to number 4. Kind of an interesting thing going on here. Notice 3x equals 9. Do you already have a variable by itself? Yes, you do. So that's the one that you're going to use. And this one is even easier than the first one. 3x equals 9. Here's the beautiful part. Notice, you only have one variable. So is that an equation that you can solve? Absolutely it is. You're going to divide by 3. So x equals 3. And in one step, you already have one of your answers. You already have half of your ordered pair. So go to your next equation, negative x plus 2y is equal to 9. And you know what x is, so you're plugging it in there. So negative 3 plus 2y equals 9. Add your 3, so 2y is equal to 12. Divide by 2, y equals 6. As an ordered pair, 3, 6 is your answer, 3, 6. Okay, good. And that was substitution, a little bit of a different version because you already had one by itself. The next one, or the last one, you could do substitution, you could do elimination. That is entirely up to you. I'm going to do substitution because the y is already by itself. So number 1, y equals negative 2x plus 8. First step is already done for you. You already have y by itself. X plus y equals 7. You're going to substitute it in there for y. So x, oops, let me change that a second. X plus negative 2x plus 8 equals 7. Again, notice you only have x's in your equation, so the y's are gone. Those x's are like terms, so 1 plus a negative 2 is a negative 1x plus 8 is equal to 7. Subtract your 8. Negative 1x is equal to negative 1. Divide by a negative 1, and x is equal to positive 1. Step 3, take it and plug it in. You have to still get your y value. So replace that x with 1. Negative 2 times 1 plus 8. Negative 2 plus 8. So y equals 6. Ordered pair, 1, 6. All right, you guys are doing great. I am going to pause this video. You guys have to watch a second video, and that is going to explain story problems. So go ahead and flip over your notes to your story problems.